negative 1. And when x is negative 1, what's y? 2. And at that point, how do you figure out this delta y thing?
dy dx times change.
Yeah, so this is dy dx times what? Times delta x. I have the change in x, exactly. So how do you figure out what that dy dx is? You need dy dx when x is what? Negative 1 and y is 2. And you're plugging it into the equation up there, right?
Yeah.
So what do you end up with when you do that? 6 times negative 1 squared minus negative 1 squared times 2, right? So what do you get? 6 minus 2 is 4. So this is going to be 4 times. What's our delta x going to be?
Well, you want 2 steps.
2 steps, exactly. So what's...
0.5.
Yeah, 0.5. So what's delta y going to be? 2. I'll put an equals 2 right there. Nice. So now what y value is?
Y plus delta.
Yeah, it's 2. The current one, yeah. So it's going to equal 4. So then you do the same thing, right? So you do dy dx when x is negative 0.5 and y is 4. So you end up with 6 times 1/4 minus 1/4 times what? 1/4 times 4, right? So you end up with, yeah, so you end up with 3 over 2 minus 1, which is 1/2. Is that correct? Did I get that right?
Yeah.
Okay. So we end up with 1/2 right here. So then we have 0, right? So then what's our y value going to be?
Wait, did you do 1
But yeah,
times
yeah.
1/2?
Oh, sorry. Times what? Thank you. Times 0.5. So that's going to be 1/4. So therefore, what are we going to get? 4 plus a fourth is 17/4. And that's what it's asking you for, right? So that's our approximation. Euler's method is using this. We're applying effectively a slope field to an initial condition. You have the initial condition f of negative 1 is 2, and then where do you go at intervals of 0.5? So you're on your slope field, and what does your slope field tell you? It tells you what direction you're moving in at any given moment, and what the magnitude of that directional change is. So you take off, oh, we only go 0.5, so you're up here. And then you reevaluate based on the slope field at that specific point. Now, could you keep on doing this? Sure. And the reason why is this Euler's method used? Like, what's the point of Euler's method? Why is that the second order? Because it's the second degree. It's got a square in there, exactly right.
Wait, is second degree and second order?
Second degree, yeah, second degree. So,
the same?
well, it doesn't. I think I was just misspeaking. It's second order right there. Yeah. So here's your second degree Taylor polynomial for f about negative 1 for any function, right? Do we know it? Can we figure out what f of negative 1 is? Oh, they tell you what it is. What is it? 2. It tells you in the question right here. No, it tells you f of negative 1 is 2, right? So it's just going to be 2 over 1 plus f prime at, we did f prime at negative 1. What is it? 4. So it's plus 4 over 1 plus, oh, excuse me, thank you, times x plus 1, right? Why is it plus 1 instead of minus 1?
Because it's x
Minus the negative, thank you. Plus a, and then hey, look at that, they told you, negative 12 times x plus 1 squared all over 2. They don't want you to multiply this out, but you can just write it as, you could write it as this if you wanted to. That would be fine. There it is. You don't have to multiply it out. Don't. I'm 99% sure that's what it says in the answer book. You have to do. And what does it say in the answer key? Take a look at the answer key. It says 0 out of 6 with no separation of variables. So if you don't even start that way, they're like, nope, we give up on you. So what do you end up with here if we want to separate variables? Well, first I would say, dy is equal to 6x squared minus x squared y dx, right? So that's 6x squared dx minus x squared y dx. So what do you have to take out? Should I take it out first? I like that better. That's a better order, yeah. So you took out x squared, so x squared like this. 6x squared minus y. Oh, if you take it out, it's not there anymore. I'm sorry, okay? Is this better?
Yes.
I'm sorry. I'm under. Okay. Is that better?
And then you
Divide by 6 minus y, so you get dy over 6 minus y is equal to x squared dx. And then what can you do to both sides?
Integrate.
Integrate. So it's going to be ln of what? Ln of what? Negative ln of this, right? Equals
1/3 x cubed.
like this, all plus c, right? Do you have to isolate y before you find the constant? No, you don't. We know that when we know that f of negative 1 is what? 2, right? So what can we do right now?
Plug in negative
Yeah,
2.
so you know negative ln of 4, and I'll just write it out so you could follow this later if you wanted to. 6 minus 2 equals 1/3 of negative 1 cubed plus c. So you have negative ln 4, you don't need the absolute value anymore, right? Equals, it's the eraser gets stuck on.
Negative 1/3 plus c.
Equals negative 1/3 plus c. So c is equal to?
1/3 minus l.
So you could do this if you wanted to. That's fine. And the payoff, it's kind of worth it. Not really, because you're not done. You have to isolate what?
You still have to isolate.
You still have to isolate it, and I kind of, I've done this, I did this now and thinking that would be helpful. It's not really, because it just means to plug in something awful at the end. So if at this point right here, it's either you find something awful now and plug it into the end, or work through it and then find something that's going to be a little smoother. If we isolate right here, what do we have to do? We know that e to the 1/3 x squared plus c equals what? Oh, we got to get rid of that negative first. Sorry. Don't convert. Don't convert without that first. Please don't. So you know that e to the negative 1/3 x cubed minus c is equal to 6 minus y. So then, oh, exciting. Y is equal to what? We add y to subtract it. So 6 minus e, this, right? And what you can do on this is just the math you see. You'll see the 6 minus like e to the negative c times e to the negative 1/3 x cubed, like that. So what do they call this? They call it like a, right? So you have y is equal to negative 6 minus a e to the negative 1/3 x cubed. Not negative 6. It is not. I don't know where these negatives are coming from. Thank you. I really don't. Usually I have some clever answer like, in an alternate universe. No. So we plug in 2 now, and we get 2 is equal to 6 minus a e to the, it's going to be negative, it's going to turn positive, right? Like this? Is that correct? I think so. So what do you end up with here? Negative 4 is equal to negative a e to the, is that correct?
Yeah.
Help me out here. So 4 is equal to a e to the 1/3. So a is equal to what? 4 over e to the 1/3. So then where do you plug that in?
Y is equal to
It's not as bad as you think, kids. Y equals 6 minus 4 over e to the 1/3 times e to the negative 1/3 x what? Cubed. So what can you actually do right here? You can simplify. It's going to be, my guess is the answer is going to be this. 6 minus what?
4. Oh.
E to the negative 1/3 x cubed minus what? 1/3. And maybe they'll write the answer like this. 4 to the times e to the negative 1/3 times x cubed minus 1. I think that's, they usually like to do stuff like that. Usually. Can you check that? Plus 1. Thank you. Look, you subtract 1. The 1 is right there, so the 1 goes away, right? But then you divide everything by what? X minus 1 squared. So then what do you create all of a sudden? What's x minus 1 squared over x minus 1 squared? 1.
And then you have to make another term.
Exactly. And then you have to make another term. So what they're doing is they're leading you by the hand to create the Taylor series for this. By saying, here's e to the x. First, build this one. So you take x minus 1 squared and plug it in for all the x's. And that gives you those. And then if you want to get from this to this, what do? You subtract 1 and then you divide by x minus 1 squared and you get the second one. Is that clearer? Okay. So then we're over something that goes to a bajillion gajillion to the gajillionth power. Gets to 0. And the ratio test says that if it goes to 0, then this will converge everywhere. It'll converge everything. Put it away, Ellie. Okay, so at time 0, it tells you that y is what? 11.4? Correct. Got it. Okay. It means he's not going up or down. So that means going up, stopping for instantaneous second, not really, and then going down. So that happens when 3.6 minus 9.8t is equal to 0. So that's going to be when t is equal to 3.6 over 9.8, which is what? 0.367. So that's the time, right? That's the time. So then how do you figure out, find the maximum vertical distance from the water? So that's when it happens. So how do you go about figuring that, the next part? Yep, from the initial point. So it's going to be 11.4 plus what? Yep. Yes, exactly. Of. So of dy dt. So 3.6 minus. Okay, I'll just keep on doing it. Right. Says find the angle theta between 0 and pi over 2 between the path of the diver and the water at the diver's instant. So what's going on here is you have this path, right? Starts at 11.4 and it goes like this, right? So what do they ask? The angle theta between the path of the diver and the water at the instant the diver's shoulders enter the water. So it's, what do you need to find here? So if you zoom in here, the angle measure is, if I were to draw this here, you know, the diver's entering like this. There's your tangent line right there, and you're finding this angle measure right here. How do you find that? Yeah, so once you're going to find the angle measure based on the line of tangency. How do you find the slope of the line of tangency right there?
dy dx.
When so you have dy dt, and then you also have over what? Dx dt when t is equal to what? A, right? So that gives you the slope of that line. And then how do you find the theta value? So this is going to equal some, let's say, q. So then what do you do once you have that slope? Tangent theta is equal to q. So theta is equal to tan inverse of q. Yeah. Make sense?